Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And students, today we are going to explore a very interesting and a very easy topic of units and dimensions, or you can call it units and measurements. So in this topic, we are going to analyze something that is also very practical that you will often come across in your lab. Not only that, it's quite easy and you often get questions from this specific subtopic of units and dimensions. So stay tuned and guys, share the video so that we can have more students on this video. And not only that, make sure you have your friends on board so that we can get into this awesome discussion. And students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top-ranking American university in electrical engineering. I'm also an IITian who completed BTech from IIT Guwahati, and I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad. And students, you can check out our Telegram channel. If you already have Telegram app, just to click on that link in the description box below. That is all you have to do, and you will be redirected to our Telegram channel. And students, or you can just type in JE_English to find us on Telegram if you already have Telegram app. If you're already on the Telegram app, else just to click onto this link, you need to first of all download Telegram app from your Google App Store or Play Store. And that being said, students, do check out the previous lectures that has been conducted by JEE English team and myself on Unacademy Learning app. And guys, like on 31st of August and on 1st of September, we had a very important lectures on physics. One of them was color coding of resistors, where you had to do nothing but had to go through few concepts, and you had anywhere around 5 questions combined in your JEE Mains 2019 just from color coding of resistors. And as you know, you get a lot of questions from electrical instrumentation, which was also conducted on 1st of September. So do check it out. Don't miss out any of these special classes conducted by our JEE English team. And we have the best educators on the team who have graduated from reputed universities across India and globe. Not only that, also ex-head of institute, famous coaching institutes. So do check on to our Unacademy app, and to download. You need to download the Unacademy Learning app to attend these lectures. All you need to do is type in Unacademy on your Google Play Store or App Store, and then you will get the first link as Unacademy Learning app, and you will right away click on that install, and there you go, you will have the Unacademy Learning app. And not only that, guys, you will get timely updates and also live notifications on the classes happening right away. So do download Unacademy Learning app if you don't have one yet. So make sure you have it and you are attending classes every now and then, and you can attend classes from anywhere. So that's the advantage of having the app even over a web version. So make sure you download the app. And guys, that being said, we have an awesome package for your JEE preparation, which comes with everything. Every technological aspect, be it on the education aspect, you get everything on this single platform. And what is this? This is a paid subscription which comes with live quizzes, live test series. Not only that, guys, you also can learn from your favorite teacher, and there are many more perks and advantages, but you also can get your doubts clear on time. It's going to be a very systematic program where you will be having weekly twice quizzes, and also every test on weekends. So it's going to be an amazing program. It's a complete package for your JEE Mains and JEE Advanced preparation. And not to say, we have the best educators across the nation on this paid subscription platform, which includes popular physics authors like PC Pandey and many more. So all you need to do is click on the extension bar and choose your first icon, and there you go, you will have your goal. You need to select your goal. You will choose your goal as IIT JEE, and guys, and then you'll get your subscription. Be sure to choose your goal right, and make sure you are motivated towards your goal, and make sure you're aiming towards advanced, be it you're preparing for JEE Mains or JEE Advanced. So aim bigger, and you will also make sure you're attaining those bigger goals. So make sure you're getting this subscription on time, because the prices right now are low. Right now, for a 24-month subscription, it's anywhere around 1,500 per month. You can avail it near about 5,500 per month. It's an awesome, economical, and a reasonable package. And as you guys know, the prices are right now very low compared to any time like in terms of subscription, and especially 11th class students, make sure you get it on time, and also ninth and 10th class students, because this is going to be a 2 years journey. Choose your 24-month subscription early, because the prices are right now low. Make sure you get it early as possible. And also like long term and dropout students, you can choose a 12-month subscription, which is going to cost you near about 2500 per month. But make sure you apply this Murli Live coupon, because if these prices you think are high, you can apply this Murli Live coupon to get a further 10% instant discount on any of your purchases. That means this is anywhere about 1400 only. So make sure you get it on time, so that you don't have to pay the extra bucks for the same value. I mean, of course, it's the best value. We have 6,000 plus materials for your JEE preparation, anywhere around, like 2,000 active courses, 2,000 active courses on this platform by very reputed educators. And but anyway, you don't want to pay more, so make sure you get it early. And also, long-term and dropout students, make sure you get it before 10th of September. Hurry up, guys, because the price hike is real and it's going to come up. Hi Srinivas, a very good evening students, and make sure you're attending this lecture thoroughly. Make sure you get your notes and your pen, guys. So every single thing that we are going to discuss in today's topic is very important. Any of the students watching this, make sure you are taking down the notes. It's very easy. All you need to be is like to be introduced to this concepts. That is all, just like any of the units and dimensions lecture. But you definitely get 2 or 3 questions from this topic, whereas this topic does not require any effort to put on your end. Especially the topic that we are going to discuss today does not require any effort, and you get a lot of questions from this topic as well. I mean, this subtopic as well in your JEE Advanced. Okay. So make sure you're making the notes along with me, and make sure you call your friends on board for this lecture. And students, hurry up, get the subscription as soon as possible, and apply this Murli Live coupon to get 10% discount on any of the packages. But make sure, like 11th class students, you take a 24-month subscription before this 10th of September. I mean, I guess there is only, probably 3 days to go or something like that. So make sure you get it early, and you get your subscription today, because the price hike is real, guys. So right now, the prices for your 2-year subscription after your coupon Murli Live is only 32,000 400, whereas if you're going after 10th of September or from 10th of September, it's even after you apply Murli Live coupon, which is going to be the best discount that you're going to avail on a subscription purchase. It's going to be anywhere around 50,400. So make sure you avail it early, because you can see it's right away 18,000 hike on this. And similarly, even 1-year subscription is going to be hiked. So make sure you get early, guys. It's a value platform. It comes with the state-of-the-art technology that puts you in the real-time environment, like what you can expect in your exam. So make sure you get it early. And that being said, today we are going to deal something very practical. An experiment is a question which science poses to the nature and measurement is the recording of nature's answers. But we want to make sure we don't have any errors in those answers by the nature. So we are going to make sure we are going to eliminate those errors through our analysis. Today, yes, we are going to get into the error analysis part. So make sure you are understanding everything throughout this lecture. And students, this is a free of cost initiative by Unacademy JEE English, is the first channel across the nation where you get all your lectures exclusively and completely in English, from the basics until you're advanced. So make sure you share this channel, and students, have your dream set. You are coming regularly to lecture. That is very important. If you have subscription, make sure you're attending test series as soon as it goes live, and also try to get all the personalized insights. Make use of the dashboards. I mean, it comes with awesome personalized insights. Make sure you are understanding your standing in every test series, in every quiz that you're doing, be it live quizzes, be it just BPP quizzes. So make sure you're learning from your mistakes, and you're overcoming those obstacles, and you keep on dreaming about getting into one of those awesome IITs that comes with awesome facilities. So that being said, do remember, so significant figures is also very relevant to our discussion. Anyway, we discussed in detail about significant figures in the last lecture. But do remember, while converting to any other system, be it from FPS to SI or SI to FPS, you should make sure that the significant figure should remain the same, right? So this is a very important clause. And that being said, we discussed about rounding off rules. So if some number is given to you greater than 5, don't worry, we'll discuss this concept again in today's lecture. I mean, a little bit of it, just to give you an intuition of how it works, very, like the critical part of it. And maybe we'll practice a couple of problems on this. And guys, why are we discussing this? Because you need to make sure you are, while you're doing your error analysis, you're rounding off the correct way. So you need to follow the right path to get that like the error analysis measurement. Okay, you'll be given options in different ways, but make sure you are following this rounding off rules. This is not just one rules. We also discussed on the arithmetic operation side. You need to follow those rules while you are doing your error analysis. And that being said, greater than 5, you need to do what you need to do is the next digit to where you have to round off until the significant figure. If it is greater than 5, you will add +1. If it's less than 5, you won't increment it. You just keep it as the same. And if 5 is the trailing one, this is where the puzzle starts. If it's a non-zero number following that 5, then what would you do? You basically add 1. And if at all 0 is trailing 5, that is after 5 you have 0, but it's an odd digit. You want to round it off with +1 to keep it even. Make sure you are always keeping things even when you have 5 trailing 0. Alright, and similarly 5 trailing 0 but with an even digit, it should be rounded off to +0. Alright, hi Venkat, very good evening. So get started on this, guys. So if you're watching it, just get started on this question. So let's say I want to round it off to 4 significant figures. Where is that 4th significant figure? This is 1 significant figure, this is 2nd significant figure, this is 3rd, and this is the 4th one. And how do you round it off? So this is greater than 5 or less than 5? This is less than 5. That means, just a moment, that means what would you do? You would not increment it. You would just, so if I'm going to round it off to only, just let's say 4 significant figures, it would just remain as 500.7 or 500 after decimal, you would just have 7. So let's say I have to round it off to 5 significant figures now. So which is the 5th significant figure? This is the 5th significant figure. It is followed by 5 now. So now how do you make decisions? There are 3 conditions before you make decision. One is if it is if the following, if the trailing digit is 5, if it is followed by non-zero, then you are going to increment it by 1. And if it is trailing 0, if instead of 6 7 it was just 0 0, and let's say so this is, in this case this is odd, so it increment by 1. If it was not odd, then you would keep it as the same. Okay, we'll see that cases as well. So if I have to round it off to the 5th significant figure, so what am I going to do? I'm going to now increment this by 1, because 5 and this 5 is followed by something that is non-zero or greater than some, like greater than 1 or non-zero. Okay, just as we understand it as non-zero. So what does significant figure tell us? Significant tells us the nearest accurate measurement. Maybe it's not the precise measurement, but it's the nearest accurate measurement. Okay, so yes, so this 5 is followed by some 5s, and you need to make sure you round it off with a +1 since this is non-zero in our case. Alright, and how about rounding it off to 6th significant figure? Which is the 6th significant figure? Again, it's going to be, I guess, 5. So 5 followed by 5. So let's understand this, how to do this. So we understood that when the 5 was the next digit to the significant figure, we had to increment it by 1 when it is followed by a non-zero thing. Okay, so again it's going to be, I guess, a non-zero 5. So you are going to, 5 followed by some non-zero numbers. So you're basically going to increment this 5. So now when I'm going to round it off to the 6th significant figure, what am I going to write? 7 4 6. Okay, here it was rounded off to 5, and here we just kept it as 7 since this is less than 5, right? And how about rounding it off to the 7th significant figure? Which is the 7th significant figure? This one. And what is it is followed by? It's basically followed by something that is greater than 5. That's it, right? So this is something that is greater than 5. So you're just going to increment it by 1. It's basically 500.745 6. And students, make sure you are following these rules in your rounding off and the significant figure rules, mathematical operation, like rounding off and significant figure rules while you are doing your error analysis. That's very, very important. So yes, let's analyze the case of 5 and let's understand how this works. 500 dot. So now what we are going to do is we are only going to round off at the fifth significant figure, which is going to be this. And now let's say I have to round it off to 500.73. I have to round off this 3 and it is followed by 5, and the next number following that 5 is 0. Nothing is written over here. So what would you do? You would round it off as, since it is even, this is just a rule, guys. Okay, I'm going to increment it by 1. Since this is odd, we have increased it by 1. Amazing, Venkatramana. That's good. That's good. Yes. Try to understand this point. This is very confusing, even for engineers, even because this is just a rule. Rest of them is very logical. When it comes to odd and even, it's just a rule. So just try to understand this point. And now it is what would this be? Yes, it's a 5 rule. Yes. And how do you round off this thing? 500 dot or 0.74 itself. Since this is even, you like to keep things even, you would not add anything, you would not increment it. And how about this? You are going to 5 followed by 5 and again followed by some zeros. So what it should be? 500.76 because 5 is odd. So this would correspond that you add plus 1 to it since it is followed by 5. Okay, and how about this? You know what it is? This is even. You would just keep it as it is. All right. So it is going to be 500.76. That's it, guys. Okay. That's about odd even. If you have any confusion, I hope you got this clarity right now at this point. So let's move on to something. So if you remember, there is something that we need to do during our mathematical operations. Okay, so this is about the accuracy that we are talking about. We don't want to make a precise calculation that actually includes a lot of errors, but we want to give a guesstimate, or we want to give the value to some extent that is more accurate than what we would do. What we think we are doing is an accurate calculation. So for addition and subtraction, you will follow the least decimal place rule. What do I mean by this? If you're going to add, let's say 1.01 plus of 2.002, this is the least accurate value, and because in terms of measurement, it's the least accurate value. Hi Manav. So guys, can you actually hear some echo? Is that true? I'll do a thing. I'll just move a little bit ahead, or maybe just move this laptop a little bit towards me. I guess now that should have gone down. And let's say now I'm going to add both of this. Which is the least accurate one? This is the least accurate one. Why least accurate? It's least precise one rather than least accurate. It's the least precise one. We do not measure it up to that third decimal point. Only we have measured it up to the second decimal point. Okay, this is the least precise value. Okay. So when I'm saying this is the least precise value, your measurement, let's say I have to add both of them, your measurement is not going to be more accurate than the least precise value. Let's understand this with some examples as we move forward. But for now, understand this point that now your measurement is not going to be more accurate than this. Like this I'm going to write it as approximate value because this is not the most accurate value. This is going to be 3.012, but this is not accurate, guys. Okay, so if I'm going to, I have to round it off. And how would I round it off? Since this is 1 and it is followed by something 2 which is less than 5, it's going to be 3.01. You're trying to keep the decimal places to 2 that is equivalent to the least precise measurement. That means that what am I trying to convey here? Like I'm trying to say that your measurement cannot be more accurate than your least precise measurement. Okay, that is the most important one. Same goes for subtraction. If I give you two values and I ask you to subtract them, that you have to make sure there are only two decimal places. If I was subtracting 2.002 from 1.01, it cannot be more precise than 1.01. And how about division and multiplication? Division and multiplication follows the least significant figure rule. What is this least significant figure rule? So we just analyzed about all the significant figures. Fourth significant figure, fifth significant figure. If you remember, for 5 we did anywhere around 5 or 6 examples. So in that example, you very well understood that what are significant figures. And when I'm talking about multiplication and division, you're going to follow the significant figure rule. Let's say I'm going to multiply some 23 into 1.1. How many significant figures are there in both? There are only two significant figures, right? There are only two significant figures. That means your product actually should not exceed your this value. But whereas you actually get if I'm going to do this like 23 into 1.1, what it is going to be 23. This is how you would do it, and you would get something like 25 25.3. So but how much would you say this value is? So just think about it as in terms of physics, like you're measuring it literally, and now you want to convey it to someone and make sure you are not making any errors. So this is approximately anywhere around. So this one you haven't measured up to first decimal place, and you have only measured the two significant figures. And whereas in this case as well, you have only measured two significant figures. Now when I am doing that arithmetic operation of multiplication on this, I'm getting something like 25.3. But I very well know that my value should be approximately only be conveyed as 25, okay, to the just two significant figures. Why? Because your measurement cannot be more accurate than the least precise measurement. In terms of multiplication and division, you are going to be worried about the significant figures. Whereas in terms of when you're doing addition or subtraction, you are worried about the least decimal place. All right. So that means that let's take up some quick problems and students get started on this. Let's say I have to add 1.11 to 1.39. Which of the following options are correct? 1.5 or 1.50 or 1.500, or whether it should be none of the above. What do you think is the correct answer, students? What should be the answer in this case? Are you sure? Venkat? Guys, what we are adding? This is addition being done. So in this case, how many decimal places we have? Two decimal places in each of them. Right? Your value can actually have up to two decimal places. That means you will convey it as 1.50. I am very confident that my value is measured up to that second decimal place. Yes, it is B. Rana, that's correct. Up to second decimal place, you are confident. Up to that second decimal place, you are sure that this is up to second decimal place. You are quite sure that this should have been the addition. Whereas in this case, you are actually conveying less accurate. Whereas in this case, you are trying to convey more accurate value. Whereas this is not the case. Okay, this is not the case. This is less accurate, which means you are saying that your addition is less accurate, whereas in this case your addition is more accurate. This you are trying to overestimate the your calculation. And whereas now in this case, what should be the answer, students? Whether I'm multiplying 1.1 into 1.1, whether it should be 1.21, 1.20, 1.2, or none of the above. What it should be? So this follows what? Are you sure? Are you sure, Rana? Like what it should be? It should follow least significant figure rule. And how many significant figures are there? 2 and 2. Yes, it is C, Venkat. That's correct. Amazing, guys. You're getting the concept. So there is nothing concept in this, but you have to understand it is practical, guys. It is very practical. I only measure up till 1.1 and 1.1. When I'm multiplying it, the answer is going to be 1.21. But you have to round it off to 1.2 while you're conveying it to say that I am sure that it should be near 1.2, something greater than 1.2, or maybe your calculation is not the most accurate, somewhere like 1.15. Maybe the real value was 1.15. In this case it was like 1.19. Actually you might get it near 1.3. So make sure you are rounding it off to the least significant figure of the measurements. Now you have conveyed a accurate value, not the precise value. I mean, whatever. So that is it, guys. That is all about you need to know before we get into error analysis. And as you know, error analysis is very interesting. It's very practical as well. Even if you get into engineering, you will do a lot of error analysis. But before that, let's explore one more problem around this concept. So among these, which are the most accurate value, guys? So you have 1.2 and 1.2 being multiplied. Let me tell you, the value is going to be 1.44. So now what should be your answer? It should be D. That's correct. That's correct, students. So why? Because you had two significant digits, just like how we did earlier. If you remember, we had two significant figures. So the least significant figures was two significant figures, and here also the least is two significant figures. Yes, that's correct. Yes, two significant figures. Okay, you don't want to do this anywhere. You want to only do this only during your problems where you have multiple options that matches. So make sure you're not messing up your paper thinking about this. This should be only done when you have either a question from units and measurements or units and dimensions, or whether you have a question where multiple options are matching but it is only one correct answer. Even if it's multiple correct answer, try to mark this question because you have the justification that this is the correct one. Okay, so where multiple options are there and they have similar value, same value, very similar value, like in this case it should have been either 1.4 like 1.44 or 1.40 or 1.44 10 to the power minus 2. So in that case you need to make sure that you are only marking or thinking about these concepts when you're doing an error analysis, when you're dealing with some questions in units and dimensions where you have multiple options that may be correct, but you know that only one option is correct. Then in that case, you are going to follow this rounding off and significant figure rule. And talking about error analysis, there is what is error actually? When you're talking about error, we are actually dealing with error every day. So there might be different kind of errors. But what is this error actually? Error is something that you are, you're expecting some value. This should have been the value. Let's say I'm traveling, 10 kilometers in 1 hour. That means you probably, exactly 10 kilometers in 1 hour. You know that my average speed should have been, 10 kilometers per hour. But whereas your speedometer is telling you, your digital speedometer, or in that case, you have some application on your phone that is telling you are traveling at 11 kilometers per hour. But as you know, in reality, the person has only traveled 10 kilometers. You are not going to upon that bumpy roads and etc. For you, that's the actual value, because someday you need to make an estimate that you need to travel 100 kilometers. Then it's going to take 10 hours, not really 9 hours. So error is the difference between the measured quantity and its true value. Okay, a true value is something that we are going to derive or something that has been predefined. Okay, a true value is something that we have already defined, or we are going to derive, or we have already defined. And a measured quantity is nothing but that we are measuring on that scale at that moment. Why am I specific about that scale and that moment? Because your true value is based on very accurate measurements. or some mathematical technique that you are making use to make sure your measurements are accurate. All right. And that being said, why do we have errors? So no one is perfect. Some of us do have, like some vision based problems. Some of us do not, exactly align it. So no one is perfect, and there are human induced errors. Everyone has some issues in terms of observation. For an example, parallax error. You are observing it, but you are not observing it correctly. You are observing here and there, small mistakes are being made. And some measuring instruments have defects. So measuring instruments, many measuring instruments do have defects, and there is also, a precision limit to every measuring instrument. Some measuring instruments are accurate up to 0.001 kg or 0.001 grams. When you're talking about jewelry, you're worried about that, singles, like zero point 0.1 gram and etc. So in that case, also there might be some error, and your measuring instrument itself is defective, and no environment is controlled for experiments. What do I mean? You can have a wind that is affecting your experiment. You're trying to maintain the temperature using some air conditioning system, etc., but still the temperature is not being maintained. So that way, no environment is perfectly controlled. And what about the last statement where I'm saying no experiment is perfectly controlled, conducted? I mean, there are always errors in the way you conduct an experiment. Okay, so these are like the common kind of errors, but some errors are induced, inherently by the instrument, which you should make sure you are getting rid of them. Yes, that's correct. So when you're talking about errors, it can be broadly classified into systematic errors and random errors. Yes, that's correct, Venkat. Venkat is saying instrumental errors and personal errors. That's correct. But broadly, we are going to classify it in systematic errors and random errors. You'll understand why. Because like they have, systematic errors and random errors have a nature. Okay, what is that nature? That is what we need to understand. So when I'm talking about systematic errors, what are those systematic errors? For an example, your instrumental errors. You have a weighing scale, and that weighing scale always measures, 6 kgs instead of 5 kgs. That being said, your that is an, like an instrumental error, because your instrument is wrongly calibrated and it cannot measure things accurately. Whatever you do, instead of, the actual value, let's say is like 5 kg, but always and always your weighing scale measures it as, the measuring value is something around 6 kgs. So that's a lot of error, and you're measuring something like 10 kgs and you are getting it as, you know like generally the error would be something like this. Then in that case, you're getting, this is the actual value that you have to measure, but your measured value is somewhere around 12 kgs. Okay, not exactly, but some way you're getting the intuition, I'm guessing. So it has error in one way. And similarly, there can be damaged instruments, your measuring scale that has been worn off, or your thermometer that does not work properly, and there can be also zero errors. We'll explore all of these concepts as we move to vernier calipers and screw gauge in more detail. So what do I mean by zero error? Zero error is nothing but your zero is not actually zero. Your scale stands at somewhere at 1 centimeter instead of zero. That is known as, so 1 centimeter is the zeroth, calibration. So it's not exactly, a calibration error, but it's sort of a calibration error. Okay, but this is not your zero calculation, and this will give the shift in only one direction. And similarly, your imperfection in experimental procedure. What do I mean by that? You're trying to do some titrations, okay, and you are given a solution with the wrong concentration. Then you're actually going to get the results always wrong in one direction. So there is always imperfection in your experimental procedure or technique. And this kind of errors also, given that you're following a standardized method, or someone has taught you to conduct the experimental procedure may not be the right way. For an example, someone told you can measure your temperature on your in your mouth, but that might not be the most accurate measurement, whereas you're measuring your using a thermometer, your temperature somewhere near your neck, etc., or using a thermostat, the value differs, right? There is some imperfection in your experimental procedure. Okay, that is also a systematic error. Vinay, we'll do that. Of course, guys. So one of the students has asked, when am I going to get started on the DPPs on units and dimensions? So there are two more important topics that we need to cover in units and dimensions. Then we'll do a lot of DPP, guys. Very, very important. We'll spend as much time as possible on DPPs of units and measurements because they are very important, guys. Very, very important and very easy, students. Very easy. Just we need a solve practice. Anyone can do it, even if you're in like ninth class and haven't touched the physics at all. If you attended few of these lectures, we'll be able to crack any of the IIT JEE Advanced or IIT JEE Mains problem. Probably IIT JEE Advanced will have mix of topics, but definitely many of the IIT JEE Mains problem that are just dependent upon dimensional analysis, etc. But keep noticing that plus or minus sign, that is where your error analysis is required. We need to also cover vernier calipers and screw gauge. And that being said, guys, what about your personal errors? The errors that you make personally, maybe because I don't have the perfect vision. I'm always noticing, like instead of 1, I'm noticing it as 1.1, or maybe I am observing things at an incorrect angle. So this can also cause errors. These are called personal errors or the errors that are induced by us. So that is going to be something that we need to get rid of. And generally speaking, they also tend to shift your reading in one direction. What do I mean by shift your reading in one direction? So in this case, in parallax error, it's going to be a little bit different. But think about a case you're weighing. We had this weighing machine, right, where it was always measuring, some extra kgs instead of what it should have been measuring, right? So that is a kind of error that happens, like every now and then you're noticing it, like instead of 10 kg it is measuring 12 kg, instead of 5 kg it is measuring 6 kg. What about your zeroth calibration being wrong? Always your reading is going to be plus 1. You need to subtract that plus 1. Okay, so that being said, personal errors also generally tend to induce errors in one direction. So systematic errors is about having those errors in one direction. For an example, in this case, you're noticing this awesome vernier calipers, but actually it has some zero errors. So it is always measuring that value with some zero point 0.1 error. So in this case, this vernier caliper is having a 0.1 zero error. Okay, that means it is always measuring the value more, like little bit more. That little bit more is nothing but 0.1. Okay, mm. So this is about systematic errors. Systematic errors induce errors or give measurements or errors in the measurements in only one direction. Okay, this is very important, students. This is very important. Yes, yes, questions. I mean questions. Yes. So, if it shifts in any direction, it is inconsistent, and you tend to observe these kind of errors in specific situations. Sometimes it can also be personal errors, but generally, we are assuming in personal errors, the person is making the same kind of mistake again and again. So, there are also errors. For an example, you are measuring something on your ammeter, and you're always getting a fluctuating value. And in this case, this is known as random errors because you cannot predict the direction of the errors, and they can lie on the any side. They can be positive, they can be negative, and they can be also of not a specific order of magnitude or specific magnitude. They are going to be of irregular magnitude. So these kind of errors are called random errors. And you very well know this random errors can be natural, like due to your environment can happen, and you can't control your environment completely. So this errors also can be due to your environment, or also can be due to something like an unexpected fluctuation in measurement, like due to your power fluctuations, etc. Let's say I'm trying to measure some resistance. I'm using my ammeter and I'm using my voltmeter, but I know the like I'm giving it a consistent EMF, but at the same time I'm getting different kind of ampere reading. That might be due to some fluctuation in the reading. Okay, so and also environmental conditions like light, like your wind, can etc. induce errors. So this kind of errors often happen. It's tough to control them, but there are many methods to do that. But that's going to be like not in our syllabus. We are more concerned about generally systematic errors. We assume that the random errors cannot be controlled. They are unexpected. But in any question, it can be given as unexpected fluctuation in voltage can be this. Voltage can fluctuate from 210 volts to 220 volts. Then in the case, you are going to make use of it. Okay. And the issue about random errors is they can shift in any direction, whereas the systematic errors have a single direction. They are going to be either positive or they are going to be either negative. Whereas your random errors can be negative, positive, and they can give different readings at different times. For an example, sometime I'm measuring, I'm getting it as 11 amperes. Some other time I'm measuring, I'm getting it as 13 amperes. Sometime I'm measuring, I'm getting it as 15 amperes. Okay, so that is something that is happening while I'm doing my measurements. This might be due to my power fluctuation, right? So these kind of errors cannot be controlled, and they can shift in any direction, and they are called random errors. Whereas systematic errors are to an extent controllable, and let's say it's a personal error, you can correct the way you observe things. Let's say it's going to be something like instrumental error, you can change the instrument. Let's say it's a zero error, you can add and subtract things to make sure it works, right? So now when I'm discussing about errors, do we have a method to get rid of this errors? Yes. Okay, I told you in the beginning the true value is something that is already given to us, or we are going to determine this true value. So how do I really determine the true value? I've taken I'm trying to measure the length of something, and I got n number of values. How do I know which is the accurate value? The best thing to do is always take the mean of the values. If let's say in this case I have measured x1, x2, x3, x4, so on till x5, so on till xn, I can get n different readings. It can be on anything. It can be while measuring the time period of your pendulum. It can be also be something like measuring some length of some given object, or it can be about anything, mass, etc. But in that case, some way to get this accurate value, that's going to be mean value. You are at least sure that your value and on average should lie over here. It is sort of the actual value. Let's say I'm going to take a measurement, and I got for those measurement, on measuring those samples, I got as measurement samples means I'm measuring it n times or something like that. I'm measuring it the first time, I got it as x1. I'm measuring it the second time, I got it as x3. x2, x3, x5, so on till xn. So what would I do? I would typically take mean of all these values. That way I know what is the near about accurate value. So I'm saying that the mean of any values is going to be the most accurate value, that near about the accurate value that we can determine. The nearest actual value is least errors. If you think about the mean value will have, it may not have the least error compared to any of the samples, but they tend to have, it can be said they have the least error in any. Okay. So that being said, let's get into some example problems and challenge problems and try to understand this concept. Let's say you measured, a length of a rectangular field, and in meters you found out the length as 3.4 meters, 3.3 meters, 3.5 meters, 3.7 meters, and 3.6 meters. So what do you think should be the true value of the field's length? How do you do this? Simply you take a mean. That is it. That is all you're worried about. So do notice the options you have given, like option A 3.50, option B 3.5, option C 3.7, option D 3.3. Okay. First of all, you know what to do. You need to take the mean. Okay. So I'm going to just calculate the mean, and that's going to be 3.4 plus 3.3 plus 3.5 plus 3.7 plus 3.6. That is it, right? And how many such measurements we have? 5 measurements. 1, 2, 3, 4, 5. You often do this in your labs, guys. You'll often do this even in your, if you are going to be even a computer science students, you're going to do this a lot. Okay. So 3.4 plus 3.3 plus 3.5 plus 3.7 plus 17.5. What it should be? Okay. Divided by 5. What it should be? Should be mean is 3.5. Right? No, not 3.5, I guess. It's 3.5. 3.5. 25, right? that should be 3.5 meters. So this is your mean value. This is going to be your actual value. Okay, your field must be near about 3.5 meters. Okay, you're going to, whenever you're going to say, you're going to talk about, like the average value, mean value. And now, so we have two options which are saying 3.5. One is A and one is B. Which should be the right one, guys? The right one, what are you going to do? Going to make sure it has the same number of decimals. In this case, forget the denominator. You are averaging it. It's a method where you are averaging things, but you are actually only adding things in a mathematical operation. Division is insignificant, right? In division, anyway, you are always going to have an actual number, right? So now you have to make sure it is with that only one decimal place, that least decimal place, that is going to be 3.5 in this case, right? Easy, quite easy. Let's move on to the next question then. So you measured the length of a rectangular field and you found the result to be 4.2, 4.3, 4.7 and 4.6. What should be the true value of the field length? True value, what you're going to do? You're simply going to get started on this, students. Get started on this, come up with the answer. What should have been the answer? Okay. I would really like to know what is the answer that you're getting, what is the answer that you're trying to guess in this case. Because this involves also something known as, we discussed earlier, like you need to apply your rounding off rules and make sure you are rounding it off in the correct way if you understood what we did earlier in the lecture. I'll start working on this. So mean of 4 values, I guess only 4 values are there, 1, 2 and 3, 4. That means our calculation should be simpler than earlier. So mean is equal to 4.2 plus 4.3 plus 4.7 plus 4.6, right, divided by 4. How much that should be? 4.3 and 4.7 added would give me 8. 4.3 and 4.7 added should give me 9. And 9 plus of 8, that is 17, 17.8, right, divided by 4. So would this go with 4? I guess so, yes. So how much am I getting? 4. Again, I'm getting something like 118. That is again 4. Again, there should be 20. 4.4. 4.45 is the value I am getting. But what is the correct value? Is the correct value 4.45, 4.46 or 4.4 itself? So this is a even number. I have to round it off to least decimal place. Least decimal place is only 2. Okay. Now I have to round it off to even. So it is only 5 followed by only zeros, even, and that should be only plus 0. So it should be 4.4. Right? Easy? So it should be option A. Okay. You're not going to say it's 4.45. Okay. That is it, guys. That's about your actual or true value. This is how you measure a true value. And when I'm talking about true value, that means every measurement had some deviation from that actual value or the true value or the average value that we measure. Okay, so we are going to call this difference between the true value and the measure value as absolute error. Okay, so this is saying that if I have n observations, I'm always getting it as, like the mean of the values are something like x, and my measurement, let's say, is x1, then I'm going to have an error anytime x1 as x minus x1. Okay, in this case it is written as delta x is equal to x mean minus x, and why this mod? Because it can be positive or negative, but we want to make sure we communicate it plus or minus. Generally, we like to communicate it as plus or minus, not just minus or plus, because we are never sure what can be the deviation. But as when I'm subtracting it, it might be sometimes plus, it might be lying on the left side of the mean or right side of the mean. But generally, we like to communicate the absolute values. Okay, so this is going to be your absolute errors, and let's say I have n such samples. So how do I calculate the absolute errors? First of all, I would calculate something known as x mean, which is going to be x1 plus x2 plus x3, so on till the n values plus of xn divided by just n, right? So what is my absolute error while I'm measuring x1? While I'm measuring x1, delta x1 is equal to mod of x mean minus x1. That's it, guys. How about the measurement in x2? Delta x2 is equal to, this is how you calculate it, right? You have that. So this is known as your true value. This is your true value. True value, mean value, near about, think about it in a practical life. You want to average out things and measure it so that your measurement is not fluctuating all the time. So this would fluctuate. I mean, this is lying somewhere, this much distance from your true value. So that is about your absolute errors, right? So on for also for delta xn, you can write it down. You can write it down for x3. You can write it down for xn. It's going to be x mean minus delta xn. Sorry, xn. You can take out the mod sometimes when you're talking about how much, whether it's lying on the left or the right. You can make sure you get it this way. For an example, if you have noticed this case, you're trying to measure something. We know the actual value is the green line, right? But we measured it at something like at the purple line. This is the measured value. What is your error? Your error was something like this. Sometimes if given just an actual value, actual measurement, actual value, that came from the factory and it does not have any errors, that time you can say that this is going to be the absolute error. This thing that is going to be the absolute error. Sometimes you have taken the mean and you said this should have been the value near about, because you have conducted n number of trials, and now you know the actual value. Okay, one trial is not going to tell you any exact value. You need to conduct n number of trials to get the exact value, and then you would take your first measurement and say this is the sort of error that you are going to get in your measurement. Okay, so let's get started on a question then. Now again, a very similar one. You have you're measuring the length of a rectangular field and you found the results in meters in the order. So it's saying first to the fifth, and they're asking you what is the absolute error in the fifth reading. So this is first reading, this is second reading, this is third reading, this is fourth reading, and this is fifth reading. What should be the error in the fifth reading is what they're asking. How do you do this? You'd simply first of all calculate the mean. I guess you already calculated the mean for a similar one, 3.4 plus 3.6, that's going to be 7, 3.77, okay, anyway, 3.4, so you're going to add them all. You can do it, you can make a habit of writing it down like this because you won't have a calculator in your exam. So you can, just combine those. That will, give you some, like a natural, I mean like a whole number or something. So this is going to be 3.7 plus 3.3. That way my calculation becomes easier. There are 5 readings, and we got this as 3.3. Yes, 3.5. Sorry, really sorry. 3.5 meters. And my fifth reading is what I'm concerned about. How much is the error while I was taking the experiment fifth? Delta x5, nothing but delta x5 should be how much? Delta x5 is equal to x mean. That's correct. That's amazing, amazing. Yes, that's correct. So yes, but you know what? now when I'm doing this, how much am I getting as the error? 0.1 meter. 3.6 minus 3.5. Okay, minus 3.5. 20.1 meter. That's correct. Okay, amazing work, Prasad. So that's how you calculate an absolute error. So, but now absolute error is about, we're talking about, so we took n, measurements, and we had some deviation in the values, maybe due to personal errors, or maybe due to the instrument, or maybe due to something else unexpected, fluctuation in your voltage or etc. But is that the right way of communicating the error? No, not of course. So when I'm going to talk about errors, I know, like, I have a deviation, that, the deviation from the mean or deviation from the actual value. And now I need to make sure I also take a mean of the errors to say that on an average. So you may say on an average, this is going to be the, value when I'm talking about, X mean. Okay, for some measurement, if I'm talking about X mean, that is going to be the value. But what about the error? There would also be a mean error. Okay, so if I have, n readings, x1, x2, x3, x4, so on till xn, I will also get errors from the actual value. This is going to be delta x1, delta x2, delta x3. How did we calculate this? I hope you remember. Delta x1 is equal to, similarly you can do this for everything, right? X mean minus mod of. So what would you do when I'm going to communicate error? For communicating error as well, I'm going to take an average of all these values. So if I measure delta x1 as the absolute error in the measurement x1, delta x2 as the absolute error in the measurement x2, delta x3 as the absolute error in your measurement x3, delta x4 as the absolute error in the reading 4, and so on till delta xn as the absolute error in your nth reading. Okay, this error in the nth reading, then you would add them all and take an average. Okay, so that's what we have done over here, right? You took an average. Hope this point is also clear. So this is quite a simple concept, guys. There is nothing in this. There is nothing in this. And similarly, you can also express your error with respect to your true value or absolute value. I mean, like actual value or mean value or actual value. Both can be used. And let's say I found an absolute error, and if I have to express the fractional error, so this is going to be mean error, like mean error, absolute error, I mean mean error of the entire thing. This basically the mean error we calculated just now. So it's going to be the mean error of the entire thing divided by the mean value or the actual value is going to give me the fractional error, the percentage of error that can occur. But in this time I'm just expressing in terms of fractions. If I multiplied it by 100, I'm going to get percentage error. Okay, error can be something like 0.1 in in a quantity that has 10 units, 0.1 units, or I can say this 0.1 is nothing but 1% of that 10 units. Right? This can also be written as 1%. So it's one, we are generally used to percentage error. Yes, Chandra. Yes, it is available in English, I guess. Yeah, check it out. It's available in English. Plus is also available in English. So 1% error, or you can say this is like 0.1 by 10. Like mean error was something like 0.1. This is like mean error. Okay. And your mean value or the actual value is something around 10. Can be mean value or it can also be actual value. If they are already given you the value, then you are going to take it with respect to this, right? So this can be expressed in both in terms of fraction. This 1 by 100th part is always an error, or 1% error you will have in your measurement. Let's get into some questions that will make our chapter more and more interesting. So now it's a very similar one, I guess. We just did it. This was supposed to be 3.5, the average value of this. So the average value. Let's say you are again measuring that length of that rectangular field, and you found the values in the order 3.4, 3.3, 3.5, 3.7, 3.6. The mean error in the measurement is how much? 0.12, 0.10, 0.1, and 0.2 meters. Get started on the students. It's a very easy one. What is the mean? That we just derive the mean. This time I'm not going to write the mean. This time the mean is nothing but 3.5 itself. Okay. And what is your error 1? Delta x1, how much is it? Delta x1 is going to give you, let's choose a different color for your values. The delta x1 is how much? 3.4 minus 3.5. How much is that? 0.1. 0.1 meters actually, that is fine. Our delta x2, delta x2 is going to be, you can take it either ways. It can be 3.5 minus 3.3 as well. It's going to be 0.2. Any guesses, students, on your end? This is a very practical subject, guys. You will use this in your labs. You will use this in your every kind of experiment or anything new that you're doing. You're going to do this. Okay, not just in terms of sciences. You will do this everywhere, guys. Statistics. Statistics is a form of science, but many places this will be involved. Right? And delta x4 is 3.5 minus 3. Okay, I think I'm going to take over here. Okay, so let's write down delta x5 over here. Three point 5 minus 3 points. How much is this? 0.1. How much is the addition of all of this? Let's do that. Okay. Okay. So yes, I just calculated this. I'm just moving on to that page itself. Delta x is equal to. So I need to calculate the mean error. Delta x1 plus delta x2 plus delta x3 plus delta x4 plus delta x5 divided by 5. Right? That is it. So delta x mean is how much? Yes, the error in first one was 0.1, 0.2 was the second one, and then it was 0, and then it was 0.2 and 0.1 divided by 5. How much is this? This comes out to be delta x mean is equal to 0.1, 0.3, 0.3, 0.3, 0.6, 0.6 divided by 5. How much is this? 0.12 meters, but only one decimal place to the only 0.1 meters, not 0.12 meters. So your option, your answer should have been C. Make sure you're getting all these answers correctly, because it's a very easy chapter. Be it error analysis, be it like significant figures, be it even especially this places, because very easy one. At the same time, you can calculate things very easily. Okay, so let's move on to the next question. So now you're measuring the thickness of an object, and you found some your measurements are like 3.8, 3.6, 4.2, 4.4 and 4.0. They're asking you the fractional errors and the percentage error in the measurement. Okay, we just learned what is fraction error and the percentage error. How do we find this? First of all, x mean, and in this case how many measurements here? We again have 5 measurements. Okay, something divided by 5. So it's going to be 3.8 plus 3.6 plus 4.2 plus 4.4 plus 4.0. All right. So that should be 20. 20.0, only one decimal place is what I'm getting. It should be 20 or 0.0. So it should be only 4.0, right? X mean is nothing but 4. How about your each error? Delta x1, how much? Going to be 4.0 minus, get into the habit of writing it as 4.0, even though you know, just for this, not for your exams, but just while you're practicing, while you're watching the lectures, because this gives you, like a sort of, like a habit of doing that. At least you'll memorize these things, like it should be written this way. And how about delta x2? 4.0 minus 3.6, going to be 0.4 meters. It's an easy chapter, guys, but you will have some combination of questions. But practice it. Don't ignore it. You don't want to do that, because it's going to be an easy one. But easy ones are meant to be like, it's scoring, right? Meant to be cakewalks. You need to make sure you are taking advantage of those. And what about your delta x4? And anyway, I'm just directly going to write down delta x5. Delta x5 is 0. 4.4 minus 4.0, that's going to give me 0.4 meters. And we very well know delta x5 is 0. 4.0 minus 4.0. Okay, so 0.2 plus 0.4 plus 0.2 plus 0.4 plus 0. Okay, so you need to calculate the mean of the errors first of all. How much is it? 0.2 plus 0.4 plus 0.2 plus 0.4 or 0.2, whatever, like 0.2 plus 0.4 plus 0.0 divided by 5. It is 1.2, right? 1.2 divided by 5. And what this would yield? 0.24, right? Yeah. So that should be written as only 0.2, guys. Isn't it? The error is only 0.2. It's less than 5. So it's going to be only 0.2. Make sure you're taking care of small things like this, understanding small things like this. This is, 5. I'm going to write it down as 0. So what is your fractional error? So I'm just calculating the fractional error. And I know what to do when I have percentage error. Fractional error is nothing but 0.2 divided by 4.0. That's going to be 1 by 20. And what would be my percentage error? Basically, okay, I'm just erasing this part. Note it down. I haven't. Give a couple of seconds, maybe in a couple of minutes. Alright, I think here's the one on the above. So what is now your percentage error? Fractional error, you need to just multiply it 100 to get your percentage error. right? There we go. Percentage error is equal to nothing but fractional error to 100. What is that? 1 by 20 into 100. That's 5. Make sure you're getting this answer. Okay. It will be 5% and 1 by 20. Nothing else. Okay. That is why we started with the rounding off concept after rounding off. Right? So that means any of your measurements can have up to like near about a 5% error in the measurement and the 1 by 20th of your in terms of units. All right. So that being said, that when I'm talking about errors in addition and subtraction, let's understand this with a very practical example. Let's say I want to add two quantities A and B. A is something like 5 plus a minus 0.5 centimeter. So this is how you express, guys. Okay. So it can be either 4.5 centimeters. So what does this mean? This means A can lie between 4.5 to 5.5 centimeter, right? And how about B? B can lie between 9 to 11. I mean, it should be 9.0. Okay, 11.0 centimeter, right? So let's understand something. What can be the maximum error that I can get while addition? Okay. So let's say I'm adding the least possible values. What are the least possible values of measurement in A and measurement in B? Measurement in A it's 4.5 centimeters, measurement in B is 9 centimeters. So if I'm adding the least values, so this way it's very logical, right? We can understand what is happening. When I'm adding the least values, I'm saying A minimum plus of B minimum. How much do we get it? 13.5 centimeters, right? And how about max value? Max value is going to be, let's do it with a different color maybe. So max value is going to be around 5.5 and 11.0. So I'm calculating this is for sum, right? Least value of sum. Okay, max value of sum. Okay, adding things. So this is going to be A max plus B max. How much is A max plus B max? A max plus B max is equal to 16.5. Okay. And let's say I'm forgetting the errors, just forget the errors, and I'm just adding the sum. How much is it? 15, right? Now, can I, can we just communicate that, sum, let's say sum is some x is equal to A plus B, then can we say that, it's something like 15 centimeters, and this is the maximum error, right? This is the maximum error in the left direction. This is the maximum error in the right direction. How much is this maximum error in the left direction? Let's subtract it from the. I mean, this is not like the accurate value that we know. Neither 15 centimeters is not the accurate value. Neither 13.5. Neither 16.5. But your sum is supposed to lie within this range. Your sum is supposed to lie within this range. How much is this? 1.5 centimeters, right? And how much is this? Minus 15, you do minus 15. How much are you getting? Here you are getting minus 1.5. Here you will be getting plus 1.5 centimeter, right? So that means your value. So this is the maximum, or I mean, like this is the least value of sum. That is what it is. And we found out maximum value of sum. We did two things, and we know the range should be between 16.5 and 13.5 and 16.5, right? So when I'm writing this, I know the error, the max error is anyway 1.5, but 1.5 plus or minus. So my sum's value, if I do the same thing, it also says the same thing. So this says that my x should lie between 13.5 to 16.5. And what was my error? Error was nothing but added twice. Okay, my error was added twice. Just add both of them. 0.5 plus 1.0. That's going to give me 1.5. So basically only added the errors. You noticed I only added the errors. Okay, just like how we did in addition, we added the errors. So that means given a quantity A and B, A is nothing but A plus delta plus or minus delta A, and B is nothing but B plus or minus delta B. What does this say? That the value of B should lie between B minus delta B to B plus delta B. Okay, that being said, if I'm going to add A and B, how would I do that? I would basically do, I mean, here, this small x is nothing but, let's say the sum is x, which is nothing but A plus B. X is equal to small a plus small b. And what about delta x? Delta x is equal to delta A plus delta B. Simple, right? We just worked it out. We just saw practically this work. Right? So how about subtraction? So again, we know this value should lie between A, the same kind of value, so it should lie between 4.5 to 5.5 centimeters. Okay. 4.5 to 5.5 centimeters. Right? Now, B, it's going to be 9.0 to 7.0 centimeters. Now, think about it. I have to subtract A and B. Okay, I have to find least difference and the highest difference. When would the least difference come? The least difference would come into play when I'm going to B minus A. Okay, I'm going to call some quantity X, which is nothing but B minus of A. Okay, I'll get the what is going to be my least difference and what is going to be maximum difference. So what is my least difference? I have to take not necessarily the least value, but max value of A and least value of B. Let's do a thing. Highlight this. I'm going to take out the least difference. In that case, which are the two quantities that I need? 9.0 and sure, we will do that case. Good idea. Yes, we'll do it. When do you want it? So, are you a JEE Advanced aspirant or something? So, What would be your least difference? Your least difference would be, so I'm just calculating the least difference, guys. Okay, use the same color. Maybe just for highlighting, we'll use a different color. What is this color? So delta x is equal to, this is going to be x minimum. Which year aspirant? I mean, like, when is your exam? Is it on 26th? 5.5. How much is the 3.5 centimeter? 3.5 centimeter. And how about if I'm going to talk about max difference, or how much is that distance, maximum distance between both? Which values you are going to choose? The max value of B and the least value of A. Okay. This is what you choose for year 27. We'll do that next week then. Okay. Paper attempting strategy, right? You can do it even last week though. So this is going to be your max difference, right? So if we subtract the one marked in the red, we'll get the max difference. X max, how much is that? 11 minus 4.5. Going to 6.5 centimeters. So X is actually lying within the range of 3.5 and 6.5. X is from 3.5. This can be the least difference, and it can have a difference up to 6.5 centimeters. Let's do a thing. Let's first of all subtract B from A the way we did earlier. Like, it's 5. Should we subtract this? Would we get it? No. We should add them. If I had subtracted them, it's going to be 0.5. Right? So I subtracted 1 from 0.5, going to 0.5, but I'm going to add them. Does this work? Yes. Take a mean of this value and put a plus or minus from the error, like how we used to do to calculate absolute value. 3.5 plus 6.5, how much is that? 10. That's going to be 5.0. And what is my error? In each case, it's only 1.5. So it's going to be plus or minus 1.5 centimeters. So even in subtraction, you're going to add errors. Okay. So even in subtraction, you're basically going to add errors. So that is very important, students. Even in subtraction, you're going to add errors. Be it subtraction or addition, you will add errors, because you just saw how we got those errors. What can be the maximum error, what can be the least error, and what can be the maximum value, what can be the least value, and we calculated that. What is this x? X is nothing but b minus a. Delta x is delta a plus delta b. Okay, that is about addition and subtraction of error. But a very important thing that I have to tell you, learn this concept perfectly and be confident about this concept, because these kind of things will come up your exam in a very indirect way, be it advanced or be it main. Okay, so let's do some problems based on this. This is like the most popular problem that you'll come across whenever you deal with the subject. So given two resistors in series combination, R1 and R2. I'm just putting them in series. In series, you'll add the resistance. Okay, The value of the net resistance in series is how much? How do you do? You want to find out net resistance. R net is equal to, so let's write down this as, just for now, this should be just only be your practice session, okay, not in your real session, guys. You don't do this, entire thing. You directly write it down as R1 plus R2, something like that. You just also add the errors. You'd add the errors, right? Subtract the errors. Do you, or would you know? You're going by sign convention. I guess so. Plus or minus comes out, it's going to be delta R2, that's it. And in subtraction as well, think about it. You invert plus minus, you can even put it as plus and minus. You'll get it. How much is this? R1 plus R2, R1 is 2 ohms, R2 is 3 ohms. Two ohms plus 3 ohms plus or minus. If you guess the answer wrong, try to notice the options correctly. I expected something like 0.3, but I intentionally got a 0.2. So how much this should be? 5 plus or minus 0.4 ohms. Right? This should be an effective resistance. Given a question like that, understand that you are being asked error analysis. Okay, being asked error analysis. Plus or minus comes into the play, guys. Least count comes into the play. We'll get into that concept. But any of this comes into the play, you are going to get into the error analysis. So make sure you understand this concept and you apply this concept throughout this session. We'll do a lot of DPPs. Don't worry about it. We'll also do some amazing quizzes on Unacademy app. But make sure you are applying this concept every now and then. Very important. It's very important. Easy questions, you will miss them out. Okay. For an example, now you have a you have to cut a piece of cloth, and you have cut a piece of cloth which is 2 plus or minus 0.5 centimeters. You're not sure whether you have cut 0.5 centimeters more or whether you have cut 0.5 centimeters less. That means your value can lie between 1.5 and 2.5. And the cloth that you got from the factory itself is 50 plus or minus 0.5 centimeter. Then what should be the remaining piece? The remaining piece of cloth. The length of the remaining piece of cloth. What it should be? Remember, students, we'll add the errors. There is no question of subtracting the errors. You can do it again. Take it as 1.5. Take this as 49.5. You'll get it as something like, you can take every such error possible and also work it out practically. Why would you get plus or minus? Or else you can just take the max value and the least value, and you understand that is the range. Beyond that, the range cannot move. Okay, so this is 0.5 error. This is also 0.5 error. So what is my error? My error is going to be 1.0 centimeter. Okay, it should have been 1.0, but anyway. And what about my actual value? Like the value that I'm expecting. That is going to be 50 minus 2, 48. Right? In this case, B minus A is 48. Delta error, you are going to add both of them. Right? I hope everyone understood this point. Right? 0.5, 0.5, we have added it. We just did, let's say A is equal to something like 2 plus or minus 0.5 centimeter. Okay, B is equal to 50 plus or minus 0.5 centimeter. And I'm going to say X is equal to, let's take this as just for this time, but make sure you have got this concept pretty accurately. That's very important. Okay, so delta B, X is nothing but A plus B. Sorry, okay, this time you're subtracting. I'm really sorry. So you're going to do B minus A, right? B minus A, and how about errors? Errors are going to be also added. B minus A plus or minus delta A plus delta B, max error that can occur. Okay, that's going to be 48 plus or minus 1.0 centimeter. Basically 0.5 and 0.5, right? That is 48 plus or minus 1 centimeter. Work it out. If you have any doubts, you can take your cloth length to be 49.5 centimeters and think that the cloth that you have cut is you know 2.5 centimeters, and see what is the length of the remaining piece of cloth. I mean minimum length. For max length, you can assume that you have cut a piece of cloth of 1.5 centimeter and the cloth's length is 50.5. It would lie within this range. So this subtraction addition told us the range within which your measurement should lie, the error that lies in your measurement, maybe that error. Okay. So let's understand the next thing, next most important thing, the most frequently asked concept around your JEE Mains and JEE Advanced. So let's say we have an equation x is equal to a into b divided by c. So we are going to deal with errors in multiplication and division. Okay. So I need to calculate this error. Unlike addition and subtraction, I know just I need to add the errors. Okay, we found out, we verified it. Now what about this? Simple thing, you can take a value and verify it, but I'm going to do something. I'm going to apply log on both sides. So I'm going to say log x is equal to log a b log x is equal to log of a into b by c. Right? Error is generally with respect to some measuring instrument, etc. etc. Anyway, let's move on and see. So I want to find out what is going to be my error in log x. Log a plus log b. This can be written as log a plus log b plus of minus of log c. Isn't it, students? That's it. Minus of log c. Right? So if I'm going to ask you what is the max error in log x, you're going to differentiate and see what is going to happen. But at the same time, in error, it's going to be all additive, no subtraction. Okay. So the max error in delta x, so if I'm differentiating it with respect to some other quantity, just assume, and we have cancelled out the quantity, delta x by x is nothing but delta a by a plus of delta b by b. Okay, and there can be an error in c which is also going to be added. Going in math, you're not going to add it, but going by physics, you're going to add them because you're measuring it. Okay, it may not be in your like well-defined equations. You're not going to do this, guys. Only generally in terms of measurement experiments, you have these kind of things coming up. Right? So what does this say? It says that the fractional error in like the quantity x, which is nothing but a into b divided by c is equal to fractional error in a plus fractional error in b plus fractional error in c. Right? And what is the value of delta x? Delta x is the error in your measurement. This is the measured quantity, or this is the derived measured quantity. Okay, the result in which you are expecting error. And what is the error in it? It is nothing but x into, very simple concept, but you get very often. Do remember that. So if I'm going to define the value of x, how am I going to say that? I'm going to say x is not just x into a into b plus c. Rather, x is equal to a into b plus c plus of delta x, or some small x plus delta x. Small x is nothing but a into b divided by. Okay. So that way you get error in be it division or multiplication, you're going to add the errors. Do remember that your C is divided, you're going to add the errors. Really simple. There is no confusion in this, I hope. We also derived it. You know how to do this. Given any quantity, you can derive this value. So this is about your error in multiplication division. This is one of the most sought out concepts in your JEE Mains and JEE Advanced, around which all your questions exist. Any of the questions that you're going to solve is going to be around this concept, but also around this. So what is this basically? So now delta x, if it's a into b into c, delta x by x is equal to delta a plus delta b plus delta c. I mean like delta a by a plus delta b by b plus delta c by c, delta x by x. Delta x is the error, right? Now I'm asking you, what is the error in this case? How are you going to do this? What is, you can apply log, but you already know the equation. I'm going to write it as a into b divided by c into c. Same thing, right? Now, what is this? Delta a by a plus of, let's take some space and write it down a little slowly. We'll understand this. Here, hope this is visible. This is visible. Okay. How much is this? Delta first multiplicand, delta a by a plus of delta a by a again plus of delta b by b. So there must be like another b over here. Okay. So there will be like 3 b's that you'd add into 3 times, and how about c? 4 times actually. Let me just write this part down. That's clear. So how many times a are there? A is there twice. A is just assume a is just just a multiplicand multiplied twice. How many times b is there? Thrice. How many times c is there? 4 times. Okay. So that means again c would come 4 times like this. Just you saw a came twice, b is going to come thrice and c is going to come 4 times. You can do it even using log. But yes, this is how it works. Delta a by a, 2 times delta a by a plus 3 times delta b by b and 4 times delta c by c. You literally add a question on this, like a derivative question on, like a form of question on this in your JEE Mains 2019. Very easy one. Delta x, and you know how to find out delta x. You will multiply this entire thing with x. Right? Quite easy. So yes, if you have a square b cube divided by c to the power 4, you would get it in this form. Delta x by x is equal to 2 into delta a by a plus of 3 to delta b by b plus of, okay, it's a plus of 4 times delta c into c. Okay, so even if you have m, what are you going to get? It's, let's say it's a to the power n, b to the power m, and c to the power k. You are going to write it down as delta x is equal to x into n times a, delta a by a will appear, and m times b will appear, delta b by b will appear, I mean, and how about c? C will appear, delta c by c will appear k times. So it's going to be k into delta c by c, right? So any given equation, you can remember that delta x by x is equal to n into delta a by a plus m into delta b by b plus k into delta c by c. Really simple, guys. Really simple. So let's take up a question and get started on this. So given to you, like a length of a triangle and a base of a triangle. length of a triangle and a base of a rectangle. Length of a rectangle and a base of a rectangle. The length is 2 plus or minus 0.2 centimeters. A base is nothing but 4 plus or minus 0.4 centimeters. Now we need to find out the area of the rectangle. How do you do this? L into B. When we do a thing, just try to calculate the least area possible. Lowest value should give you the least area possible. What should be the max area possible? Are you really getting the result we should be getting? Verify it and comment it below. Okay. There's nothing in this question. Let's just do it over here then. What is your okay? No space. Do a thing. Let's take up a page and do this. Your length was given as 2 plus or minus 0.2 centimeters. What about your breadth? Our base was given as 4 plus or minus 0.4 centimeter. Right? This is what is given to you. So I'm going to say A is equal to some A plus or minus delta A. I know how to calculate A. I'm saying this is nothing but L plus or minus delta L. This is nothing but B plus or minus delta B. A is how much? Small a is nothing but L into B. That is 2 into this 8.0 centimeters. Right? And how about delta A? Delta A nothing but, let's do it this way, delta A by A. Okay, sorry. Okay, let's take up a different color so that this is more comprehensible. Right? Delta A by A is equal to delta L by L plus of delta B by B. How much is this? 2 divided by 0.2 divided by this delta L, right? What about delta B? Delta B is 0.4 plus 0.4 divided by 4. This is 0.1. And error, you will add them. Okay. Then with 0.2 centimeters square, not yet. To make it 0. Delta A is equal to how much is, so this is just no units, I guess. The error units. A into 0.2. Right? So you got delta A by A is equal to 0.2. So yes, no units, right? So what should be your delta A? Delta A is nothing but A into 0.2. How much is that? 8 into 0.2, I guess. Right? 8 into 0.2. How much is delta A? Delta A is A into 0.2. How much is that? A, we know value of A. Right? That is 8 into 0.2. How much is that? 1.6 centimeters. So what should be your area? Your area should have been basically 8 plus or minus 1.6 centimeters square. Really simple. Okay, let's check out which is that one. That's B. Sorry, it's C. 8 plus or minus 1.6 centimeters square. Right. So now this was one of the JEE mains, or I don't know, like one of the competitive exams question. Given to you a density of a material in the shape of a cube is determined by measuring three sides of the cube and its the relative measuring errors. Okay, in the mass and the length are 1.5% and 1%. What is the maximum error in the density? There should be 2.5%, 3.5%, 4.5%, or 6%. Okay, what should be the error in the calculation? Let's first of all understand it's a cube. Volume is equal to just L cube. And how much is the delta L? Delta L is nothing but 1%. Okay, delta L by L is 1%. Okay, delta L by L percentage is 1%. I'm just writing it down as 1% for now. And we are given the mass. What is density? Density rho is equal to mass by volume. That is mass by L cube. Right? And if I'm going to talk about delta rho by rho, that's all I need. Into 100 is what I need. Okay, into 100 is what you need exactly, but anyway. Now let's just write down these two things properly. Delta L by L percentage is how much? 1%. And delta M by M percentage is how much? 1 point. Right? And delta rho by rho into 100. Let's first of all understand the same thing is going to happen over here. If I'm going to say delta rho by rho percentage, same as calculating delta. So multiply, 100 on both sides, that's basically percentage. Okay. Let's just keep it as this color itself. Okay. This is going to be delta M by M plus of 3 into delta L by L. Not one times, but thrice, guys. Okay. 3 times, the error can be as maximum as this. Right? Delta L by L. So how much is that in terms of percentages? If I'm going to multiply on both sides by 100, assume I'm multiplying both sides by 100, this should have been 1%, or 1.5%. 1.5% plus of 3 into 1%. How much is that? That is 4.5% in total. Right, that is how much error you have in. So delta rho by rho is nothing but delta rho by rho. Let's erase this. And let's delta rho by rho. What did I do over there was nothing but delta rho by rho into 100. Nothing but I'm saying that it is delta L by L. Okay, delta M by M delta M by M into 100 plus of right. 3 into delta L by L into 100, right? So we know this is how much? 1.5%, and we know this is how much? This is 1.5%, and how about this? This is 1% into 3. 3 into how much is that? It is going to be 4.5%. So this is going to be your maximum error in determining density. Max percentage error in your density. Very practical question. What can be your worst estimate of your density? Can go out by 4.5. Right? Really simple one, guys. If you miss out this chapter or if you don't understand it, do it again and again. Very, very simple one. But people do miss out this question. You can directly do this actually. Delta rho by rho is equal to delta M by M plus of 3 of delta L by M. The first time, take a little bit of time. Okay. And that being said, do understand one of the most important things. Whenever you're calibrating something, measuring something, there is something known as least count that scale can handle. What do I mean by that? That scale can handle. For an example, over here, this scale can measure up to this decimal. Some 0.0001. It cannot measure beyond 0.001. It cannot measure something, like what I mean is like it can't measure something like, let's say I have, this is a jewelry weighing machine. It would be pretty accurate, but still it can't measure something like 0.15 grams or something. It's not possible, right? It's not possible that it can measure beyond 0.001 grams. So 0.001 grams is the best precision it can deliver, which means least count tells you the maximum precision that instrument can measure. So your error can lie. So in this case, my value, let's say I had to measure 0.00 5 grams of gold. Okay, 0.005 grams of gold. Or else let's say we measured 0.05 grams of gold. But it could have been something like 0.005, like 99999, but still this may be measuring only 0.5 grams of gold. So it's near about 0.6 grams, 0.006 grams. But this one only measuring 0.5. So least count in a way tells you what is the maximum precision up to which it can measure. Okay, it's very important, guys. Very, 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 very important. Even moving forward, we're going to deal with lots and lots of least count based questions as well as in a JEE Advanced. Okay, 0.005 grams of gold. If I'm going to talk about measuring 0.005 grams of gold, but in reality, your machine is not measuring something near 0.6 grams. So there can be a plus or minus a least count based error. Even though it's a precise instrument, it has some error. Okay. So that is the thing. Like, in this case, my, jeweler measuring scale could have only measured 0.001 gram of gold. It cannot measure 0.0099 grams of gold. So it still has some error. But how does this, least count talk about your precision? So for an example, in this case, this is a meter scale. And you very well know this meter scale. Let's just assume we have centimeters more accurate than inches, but we are just going to deal with the centimeter part of it. And you see that the centimeter is divided into 10 parts, right? Between 1 and 2, 10 parts, 2 and 3, there are 10 parts. So that means this scale can measure up to like 0.1 centimeter. So it may have an inaccuracy of 0.1 centimeters in your measurement. Maybe it is lying somewhere in between, 2.5 and 2.6. You're not saying that it is lying between 2.5 and 2.6. You're probably saying 2.5 centimeters or 2.6 centimeters, depending upon like what you think it is. But let's say if I'm dealing with the vernier calipers, like this digital vernier calipers, which can measure up to 0.01 millimeter, that means it is 100 times more accurate, like 100 times more precise value than what your scale, your that meter scale can give you. So vernier calipers is capable of measuring up to 0.01 millimeter, accuracy. The least count is far better than meter scale. That means it's more accurate. In that case, you are struggling to deal with 0.1 centimeters in the meter scale, whereas now you can measure up to 0.01 millimeter. Okay, that is literally, I think, 100 times that value. Okay. So it's like it can measure values with better accuracy. That's what least count tells you. For example, in this case, I'm measuring some temperature on some old school type thermometer, where I am able to only measure up to like one is the least count. That means this thermometer, if I'm measuring somewhere around let's say 24 in this case, it can be the 24. I think in this case it's 22 degrees. Okay. Anyway, so 24 in this case, it may be 24 or it may be 23 or it may be even okay, maybe 23, 24 or 25, perfectly controlled, but the 23 is not really 23 what I'm measuring. Or 24 is not really 24 is not really 24 what I'm measuring. Can be 23, it can be 25, etc. So this is one of the this precision. I mean, like least count actually determines the precision. It determines the precision of a measuring instrument. What does least count do? It determines the precision of your measuring instrument. Right? You understood very well how to calculate least count. You look at the scale, you see what is the least or the most precise value it can measure, the maximum precise value it can measure, and then you say, okay, this scale, this measuring instrument has so much least. Okay. So let's move on to an interesting question that was asked in JEE Advanced. Anyway, if you're not aware of meter bridge, well and good. This is a combination of meter bridge and your least count based like a problem. So here you have a balancing length of a jockey at 40 centimeters. So let me, if you're totally new to this concept, let me quickly give you an overview. So if this is length L1 and it has been balanced, so this instrument over here gives you zero deflection. Okay. Now you can also go and watch the last two lectures to understand this concept. And this is L2 of current electricity, or one of the electrical measuring instrument lectures on Unacademy learning. If it is L1 and L2, then if this is resistance R and 90 ohms, then you would say R divided by R divided by 90 is nothing but L1 by L2. These two would be, and the ratio of these two would be equal. Okay, that is all about your meter bridge. All right. This was a typical question asked in your JEE Advanced. So now, okay, what to do? L1 and let's say this L2, then this is nothing but R by L1 is equal to 90 ohms is what is given over here. Notice it carefully, by L2. And how much is this? Like 40 centimeters. And one more thing, guys. So if this is 40 centimeters meter bridge, so this is going to be 60 centimeters. Right? This is nothing but 90 by 60 centimeters is equal to something like R, that is an unknown resistance. You put an unknown resistance generally in the left gap to find out what is the resistance of that unknown resistance. And this is 40. And from this, R is nothing but, you can do this calculation. This is a very simple math. You cancel out the 0, you take this 4 on the numerator, and you would get it as by 2R. This 2, 3, and that would be 60, right? R is nothing but 3 ohms, right? And how about your delta R? You have delta R in your question. Yes, you have delta R in your question. So that's 260 ohms. One of the delta R is only that, either 0.25 or 0.15. We don't know. What is the least count of the meter bridge? It's 1 mm, guys. 1 mm is the least count. This can be the maximum precision, or this can be the error. This is the possible error in your measurement. Okay. And now you know delta R. Okay, first of all, let me just take you through this concept a little bit. So what we add, something like this. I'm just directly writing down the equation. R divided by L1 is equal to X divided by, can be written that way as well. And but anyway, let's not mix it up and let's write it down. R by X is equal to, X in this case is known, okay? X in this case is 90 ohms. Generally, X is written for unknown, but here we are given R as unknown. So R by X is equal to L1 by L2, right? I can take this X on the other side. That means R is equal to X into L1 by L2. Correct? So let's do a thing. Let's take the, right? This is constant 0. And in case of delta L1, what is the value of delta L1? Delta L1 is nothing but 1 millimeter, which is 0.1 centimeter, and you have the value of length 40 centimeters. Going to plug in that, and you have a 0.1 again, because it's the same length on the same scale. And how much is this? This is 60. Okay, this is nothing but 60, right? Let's do a thing. Let's erase one of them and find out value that we should be getting. Okay, so I'm just going to erase the one on the top. That means this should be delta R by R is equal to 0.1. So just add them both. If you add them both, it's going to be 4 plus 6. That is 10 by 14 to 60. Cancel out 1. It's going to be 1 by 240 or something like that. But delta R, how much is the error in R? R is equal to R into 1 by 240. That is equal to, how much is the value that we just found out? 60, right? 60 divided by 240. That's going to be 4, right? It's going to be 4. Just erasing the students. So that should be just 1 by 4, right? 0.25, I guess. Okay. Delta R should be this is 1 by 4. We calculated just delta R. Well, we know the value of R is 60. 1 by 4, that means it is nothing but 0.25. Value of R is nothing but R plus or minus delta R. The final answer should be like plus or minus delta R. That is going to be how much? That is like a 60 plus or minus 0.25. It's really easy. This is the easiest question in a meter bridge that you can get. Not easier than this. Actually, if you go through the meter bridge concept, it's going to be the easiest ever problem that you'll see. But students, if you didn't know this concept of error analysis, you missed it out. Right? 4 or 5 marks, I don't know how much was this. So this was a very, 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 very easy one that you could. cracked without any hassle. Right? Quite easy. All right, students, that's it for today. We'll do more and more problems in BPPs. And do not forget to share this channel. It's very important that you share this channel on the all possible social media. Do share it on your, like Telegram, your Twitter, or like whatever, like, your Facebook, etc. It's important that you share this channel so that, someone in need may get access to this free of cost lectures. Make sure you share the channel, you keep acquiring the knowledge, but at the same time, you have to share the knowledge to make sure humanity progresses and as well as you progress very well because you tend to discuss with your friends. And make sure you keep smiling, guys, keep smiling, avoid gossips, and make sure you work hard towards your success. That's also very important that you don't get agitated by any other things happening around you. Make sure you work hard towards your success, acquire knowledge, and keep sharing. Do not forget to share the channel. And students, if you are already on Telegram app, just click on to this link that is available in the description box below. Else just type in JEE_English and you will be able to find our channel. This is like the place where you will get all the updates happening on JEE English, be it your special class, Unacademy learning app, like that one-stop place for all the updates. So make sure you get onto this channel, and if you haven't yet completed the lectures on Unacademy Learning app, and where we discussed anywhere around 5 model problems just on that easy topic called color coding of resistors, it's the easy cakewalk, guys. So do check it out. It's JEE Mains 2019. You had anywhere around 5 questions combined, and also we completed, the special class on electrical instrumentation. Soon we'll be also hosting a special class on projectile motion, and we have also completed the problem set. So do check out, the lecture series on Unacademy Learning app as well. They are all free of cost. And to attend this free of cost lectures, you need to download Unacademy Learning app. And even if you have subscription, do download the Unacademy Learning app so that you can attend classes from anywhere. Not only that, guys, you will get all the notifications, live notifications, and timely notifications for all your classes. So make sure you download the Unacademy Learning app. And guys, you need to click onto the extension bar and choose the first icon and click your goal as IIT JEE and then get your subscription. Yes, it's a paid subscription. What does it come with? So this is like in the app is free of cost. This is a paid subscription. You get to attend many free lectures, be it on your Unacademy Learning app or JEE English. So do share the channel, do like this video so that and also share the channel, guys. Share the video, share the video. And what is the subscription then? This subscription is about a complete package for your test preparation, JEE preparation, both your JEE Mains and JEE Advanced. It comes with weekly quizzes, a very systematic program. Not only that, there are many live quizzes, live test series. You get to learn from your favorite teacher and your favorite educator, and you can also get your doubts cleared on time. It's an amazing platform that is equipped with the state-of-the-art technology that comes with everything that you need for your JEE preparation. You get to sit in this platform just like how would you experience in your exam. So make sure you get it all. It comes with all the personalized insights that is required for your improvement in your test. And students, make sure you get it early because from 10th of September, the prices are going to be high. Make sure you apply Murlidharan coupon and you get this 10% discount before 10th of September. And guys, make sure you get it early, especially 11th class students. Hurry up, guys, hurry up. Right now, the prices for for the 2-year subscription is anywhere around 32,400 after you apply Murlidharan coupon, which is pretty economical. I guess after 10th of September, it's going to be 50,400 and 18,000 hike in prices. So make sure you get it early, guys. Early means early. We have the best educators. Don't miss out this opportunity. Don't spend extra money. If you avail it before 10th of September, it's going to be this cost. And students, right now the prices are low. Make sure you get it right now. And for 24-month subscription, it's going to only cost you near about 1,500. And after you apply Murlidharan coupon, there is going to be a 10% instant discount even on this price. So make sure you get it early, guys, so that you don't want to miss out this opportunity. And also long-term and dropout students, right now the prices are low. Try to get it right now so that you get the best price and the instant discount. Do not forget to apply the Murli live coupon to get your best in class discount on your purchase. Take care, stay safe, bye bye. See you in the next class, and also see you tomorrow. Do not miss out the next class. Do check it out. We have also started with capacitors. Be 2021 or 2022 aspirants, keep attending the classes. Make sure you are regular to the lectures. See you in the next lecture, students. Take care, stay safe. Bye bye.